and welcome to the video on adding vectors. When you add two or more vectors together, the answer that you get is called a resultant vector. And to get that resultant vector, there are four main steps that you'll have to take. The first two go together and they can go in either order. You'll want to sum the horizontal components of all your vectors, sum the vertical components of all your vectors, use trig to find the angle of the resultant vector, and then use the Pythagorean Theorem to find the magnitude of the result. When we do these first two steps, we're going to use something called summation notation. And it uses this symbol here. It's a Greek letter, it's a sigma, and it means summation. It just means add everything in the set that you're going to write after it. So let me show you what this might look like. Well, first off, I guess let's take a look at our vectors up here for the example that I want to do today. I've got three vectors that we're going to add, and they all start at the origin on the coordinate plane. And just like before, I want to take the time before we start to measure all the vectors from the positive x-axis. So that way, the angles all start here, and that's a good shortcut to use to make sure that you're getting the right values on your horizontal and vertical components. So let's take a look up here. The first vector I have is 40 pounds of force, and it's at 20 degrees. Now this one is already measured from the positive x-axis, so it's good to go. We don't need to do anything with it. The second vector down here is 60 pounds of force, and right now it's measured as 20 degrees off of the negative x-axis. So let's get a measurement all the way around to see how many degrees this is. So from positive x-axis over to this vector, this would be here to here is 90. There's another 90 to give us 180, and then 20 more degrees gives us a total of 200 degrees from the positive x-axis. Same thing for this 55-degree pound force down below. It's 10 degrees off the negative y-axis. So if you want to go from the positive x-axis all the way around to this vector, you ask yourself, okay, well, I've got 90, 180, and then all the way over here would be 270, but I want to back it off 10 degrees. So 270 minus 10 would give you 260 degrees. And then those are the angle measures that we'll use when we do our calculations. So as step number one said, let's start by summing the horizontal components of the three vectors up here. I'm going to use the formula to show, hey, right now I'm doing the forces in the x direction. I've got first this 40-degree pound force at 20 degrees. So the horizontal component of that would be the magnitude of the force, which is 40, times the cosine. Remember, we're doing x, so that's cosine. The cosine of the angle, which is 20 degrees. There's the horizontal component of the first vector. Second vector is the 60-pound force, so that would be the magnitude, times the cosine of that angle. And remember that we're not using 20 degrees here, we're using 200 degrees. So the cosine of 200. Plus, the third vector is 55 pounds of force, that's the magnitude, times the cosine of 260 degrees. From here, your job is to grab your calculator, throw it all in there. We've got 40 times the cosine of 20, plus 60 times the cosine of 200, plus 55 times the cosine of 260. I end up with negative 28.3, I'm going to round to the nearest 10, negative 28.3, and then that would represent the horizontal component vector. That's 28.3 pounds of force, and it's negative. That tells you in the x direction the resultant vector is going to be pointing towards the left. Let's do the same thing for the vertical. The sum of the forces in the y. Now here's a sweet trick that you can use. The horizontal component used cosine, the vertical component used sine. So all you have to do is take this equation that you used for your horizontals and change it over so that instead of cosine, you have three sines in there. So I've got 40 sine of 20 plus 60 sine of 200 plus 55 sine of 260. Parentheses over there. There we go. And just like last time, pop them in your calculator. So 40 sine of 20 plus 60 sine of 200 plus 55 sine of 260. I ended up with negative 61. 0.0. And again, that's pounds of force. So again, this one came out negative, which means that our resultant vector is going to be pointing downwards in the negative y direction. So how do you finish this problem? You're not done yet. These are the two component vectors that make up the resultant vector. But I want to know overall what's the magnitude and what's the direction of this final resultant vector. So let's draw one more diagram up here in the corner. I have a new coordinate plane for us. And I'm just going to make myself a quick little drawing showing a vector that goes to 28, about 28 or so, 28.3 in the negative direction over here, and negative 61 in the y direction. So again, this is just a scratch drawing. It doesn't have to be exact or anything like that. But I'm going to use this to help me find the magnitude and direction of this final vector. So there are my two resultants that I just found. Now if you remember, we're kind of working backwards from before. When you were finding component vectors, I told you to make a rectangle around the diagonal vector that you are working with. So right now I've got the two sides of the rectangle. The vector that is our resultant, we'll pretend like that's a straight line, is going to look something like this. And again, it's just like, it doesn't have to be the exact amounts or anything. It's what it's labeled. It's not necessarily that I took out my ruler and drew it exactly 28.3 units long. All right, let's find this angle. Now, in this picture right here, you can see there's a couple different ways you could find the angle. You could search for this little part up here and add it to 180. I'm going to find, let's do this one right there. Let's find this angle measure. We're using trigonometry to find this angle measure. Now, in this triangle, if you look at this bottom triangle right here, there's a right triangle. I'm looking for this angle, and I know one side, and I actually know this other side down here as well. This is 28.3, since it is a rectangle, remember? Now, I want to find this angle, and I know this is the hypotenuse, and this is the opposite side, and this is the adjacent side. I know opposite and adjacent, so the trig ratio you should use to find this angle measure is tangent. Tangent is opposite over adjacent. So let's do a little calculation over here. The tangent of theta equals opposite over adjacent. Opposite is 28.3, so we'll say the tangent of the angle is 28.3 divided by the adjacent, which is 61.0. And if you remember from before, this is when we use inverse trig to find the missing angle measure. So inverse trig on both sides, we're left with the inverse tangent of 28.3 over 61.0. Pop that in the calculator. Inverse tangent of 28.3 divided by 61.0. I end up with 24.88. Let's round off to the nearest tenth again. How about 24.9? And that's degrees. But now watch out, because if I'm going to be consistent with all the problems I'm doing, I'm always measuring my angle from the positive x-axis. So this angle right here is measured off the negative y-axis. So let's think about this just like we did the last one here. If this is 24.9, right in there, how far is it from the positive x-axis? Well, it would be 90, 180, 270 would take you all the way here, but let's back it off then. So 270 minus 24.9. Now leaves me with 245.1 degrees. 245.1 degrees would be the angle measure of this result. Now only one step remains, and that is to find out the length of the resultant vector, as in the magnitude. How strong is the resultant force? So you've got enough information here in this triangle. If this represents 61 and this is 28.3, you use the Pythagorean Theorem, a squared plus b squared equals c squared, to find the length of the hypotenuse. So let's do that calculation up above here. A squared plus b squared equals c squared. Remember that c is the hypotenuse, and that's the one we don't know. So 61 and 28.3 go in for a and b. I'm going to make us some room here. 28.3 squared plus 61 squared equals c squared. And let's go ahead and calculate that together. 28.3 squared plus 61 squared gives you 4,521.89. And then you have one step left. Remember that you can't stop here. You have to get rid of that square. Opposite square to square root. So the square root of 4,521.89 comes out to be 67.2. And that's pounds of force. So overall, you see we've got a lot of calculations going on here. It is really important that you keep your work organized on your paper. I tried to keep everything splashed in here so you can see it on the camera. But I really recommend labeling the areas that you're working with. Talking about here, labeling, I'm doing forces in the x direction, forces in the y. Here I'm working with the angle. Here I'm working with the magnitude. That would be really helpful to you as you're first learning how to do these calculations. So to finish this off, teachers would love to see your work all together in the end, what your final answer is. So I would say let's tell our teacher that the angle is 24.9 degrees and that the magnitude of the force, so we'll just call it F, is 67.2 pounds of force. And put a box around it or something like that to make sure that it stands out. And you can say, this is my final answer. I hope you've enjoyed this section on adding vectors. Next up, we'll talk about external forces and how to find them.